Hey everyone! Welcome back to Math Minds Unlocked, the channel where we make complex math concepts simple, fun, and interactive. Today we're diving into one of the most fascinating topics in group theory, the Sylow Theorems. Whether you're a math enthusiast, a student preparing for exams, or just someone curious about abstract algebra, this video is for you. By the end of this video, you'll not only understand the Sylow Theorems, but also see how they connect to the bigger picture of group theory. Let's get started. First things first, what are the Sylow Theorems and why should we care about them? Well, the Sylow Theorems are like the Sherlock Holmes of group theory. They help us uncover hidden structures within finite groups, especially when it comes to subgroups of prime power order. These theorems are named after the Norwegian mathematician Peter Ludwig Sylow, who discovered them in 1872. But don't worry, we'll break them down step by step so they're easy to understand. Before we dive into the theorems, let's make sure we're on the same page about some key concepts. A p-group is a group where the order of every element is a power of a prime number p. For example, if p equals 2, then the group's order is 2, 4, 8, 16, and so on. Got it? Now let's take a group like G equals E, A, B, C, D, F with order 6. The Sylow theorems help us answer questions like, how many subgroups of order 2 are there? How many subgroups of order 3 are there? And how do these subgroups interact with each other? These questions might seem simple, but when we scale up to larger groups, things get really interesting. Alright, let's meet the three Sylow theorems. Here they are. First Sylow theorem. If G is a finite group and P is a prime dividing the order of G, then G has at least one Sylow P subgroup. Second Sylow theorem. All Sylow P subgroups of G are conjugate to each other. Third Sylow theorem. The number of Sylow P subgroups divides the order of G and is congruent to 1 modulo P. Don't worry if this sounds a bit abstract right now. We'll unpack each theorem with examples and visuals. Let's take S_3, the symmetric group on 3 elements. Its order is 6, which factors into 2 times 3. According to the first Sylow theorem, S_3 must have subgroups of order 2 and 3. Let's find them. The subgroup of order 3 is E, 1, 2, 3, 1, 3, 2. The subgroups of order 2 are E, 1, 2, E, 1, 3, and E, 2, 3. See how the first Sylow theorem guarantees their existence? Now let's check the second Sylow theorem. Are these subgroups conjugate? Spoiler alert, yes they are. Conjugacy is like a symmetry within the group. 2 subgroups H and K are conjugate if there's an element G in G such that GHG1 equals K. In S_3 you can check that the subgroups of order 2 are all conjugate to each other. This is exactly what the second Sylow theorem tells us. Now let's talk about the third Sylow theorem. It tells us 2 things. The number of Sylow P subgroups divides the order of the group. This number is congruent to 1 modulo P. For example, in S_3, the number of Sylow 2 subgroups is 3. Does 3 divide 6? Yes. And is 3 congruent to 1 mod 2? Well, 3 minus 1 equals 2, which is divisible by 2. So, yes again, the third Sylow theorem holds. Now you might be wondering, why are these theorems so important? Well, the Sylow theorems are like a Swiss Army knife for group theorists. They help us classify finite groups, understand their structure, and even solve problems in other areas of math, like number theory and geometry. For example, they're crucial in proving that every group of order 15 is cyclic. Let's try a problem together. Suppose G is a group of order 28. How many Sylow 7 subgroups does G have? Using the third Sylow theorem, the number of Sylow 7 subgroups divides 28 and is congruent to 1 mod 7. The divisors of 28 are 1, 2, 4, 7, 14, and 28. Which of these are congruent to 1 mod 7? Only one. So, G has exactly 1 Sylow 7 subgroup. This means the Sylow 7 subgroup is normal in G. Cool, right? I hope this video helped you see the beauty and power of the Sylow theorems. They might seem intimidating at first, but once you break them down, they're incredibly elegant and useful. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon so you never miss out on our math adventures. And hey, drop a comment below. Let me know what topic you'd like us to explore next. Thanks for watching, and remember, math isn't just about numbers, it's about unlocking the secrets of the universe. Until next time, keep exploring, keep learning, and keep unlocking your math mind. See you soon. Visual, a montage of upcoming video topics with a call to action to subscribe.